Q3328. The purpose of the lead lag, drag, hinge in a three-bladed, fully articulated helicopter rotor system is to compensate for A. Coriolis effect, B. Coning, C. Geometric unbalance. The correct answer is A. In a fully articulated rotor system, each rotor blade is connected to the hub through a vertical hinge known as a drag or lag hinge. This hinge allows each blade to move independently of the others, enabling them to oscillate back and forth in the plane of the rotor disc. This motion is referred to as dragging, lead lag, or hunting. The drag hinge, along with dampers, serves the purpose of absorbing the acceleration and deceleration of the rotor blades caused by the Coriolis effect. The Coriolis effect is a phenomenon that occurs due to the rotation of the rotor disc. As the blades rotate, the changing velocity of the blades in relation to the rotating disc can result in centrifugal forces and lead lag motion. By incorporating drag hinges and dampers into the rotor system, the oscillating motion of the blades caused by the Coriolis effect is dampened. This helps to maintain rotor stability, minimize vibrations, and ensure smooth and controlled rotor operation. The drag hinges and dampers play a crucial role in maintaining the integrity and performance of the rotor system in a helicopter. 3329. High airspeeds, particularly in turbulent air, should be avoided primarily because of the possibility of A. An abrupt pitch-up, B. Retreating blade stall, C. A low-frequency vibration developing. The correct answer is B. In forward flight, helicopters experience a phenomenon called retreating blade stall, which can limit their forward airspeed. Retreating blade stall refers to the tendency of the blade on the side opposite to the direction of flight, retreating side, to stall or lose lift. This occurs because the retreating blade experiences a higher angle of attack and a lower relative wind speed compared to the advancing blade. Several factors contribute to the likelihood of retreating blade stall occurring during high-speed operations. These factors include 1. High gross weight. Increased weight places greater demands on the rotor system, making it more susceptible to stall. 2. Low RPM. Insufficient rotor RPM reduces the margin of safety and increases the risk of stall. 3. High-density altitude. High-altitude operations with thin air result in reduced lift production, making stall conditions more likely. 4. Steep or abrupt turns. Aggressive maneuvering or rapid changes in direction increase the angle of attack on the retreating blade, elevating the risk of stall. 5. Turbulent flight. Turbulence causes erratic airflow over the rotor blades, which can disrupt the smooth lift production and lead to stall conditions. To mitigate the risk of retreating blade stall, pilots must operate within the established airspeed limitations and ensure that the helicopter is properly configured for the given flight conditions. This includes maintaining appropriate rotor RPM, considering weight and balance limitations, and avoiding abrupt control inputs or maneuvers that could induce high angles of attack on the retreating blade. By understanding the factors contributing to retreating blade stall and adhering to safe operating practices, pilots can effectively manage this limitation and maintain safe flight operations. 3330. The maximum forward speed of a helicopter is limited by A. Retreating blade stall, B. The rotor RPM redline, C. Solidity ratio. The correct answer is A. The maximum forward speed of a helicopter is limited by retreating blade stall. Retreating blade stall occurs when the airflow over the retreating blade becomes insufficient to sustain lift, leading to a loss of lift and an increase in drag. As forward speed increases, the retreating blade encounters a higher relative airflow speed, reaching its critical angle of attack and stalling. This limits the helicopter's maximum forward speed. 3331. When operating at high forward airspeeds, retreating blade stalls are more likely to occur under which condition? A. Low gross weight and low density altitude. B. High RPM and low density altitude. C. Steep turns in turbulent air. The correct answer is C. The tendency for the retreating blade to stall in forward flight is indeed a significant factor in limiting a helicopter's forward airspeed. This phenomenon, known as retreating blade stall, occurs when the retreating blade reaches a higher angle of attack and experiences reduced lift compared to the advancing blade. Several conditions can increase the likelihood of retreating blade stall, especially when operating at high airspeeds. These conditions include 1. High gross weight. A heavier helicopter places greater demands on the rotor system, making it more susceptible to stall at higher speeds. 2. Low RPM. Insufficient rotor RPM reduces the margin of safety and increases the risk of retreating blade stall, particularly at high airspeeds. 3. High-density altitude. Operating in high-density altitude conditions, where the air is less dense, reduces the rotor's ability to generate lift, making stall conditions more likely. 4. Steep or abrupt turns. Aggressive maneuvers or sudden changes in direction can increase the angle of attack on the retreating blade, leading to stall conditions. 5. Turbulent flight. Turbulence causes irregular airflow over the rotor blades, disrupting the smooth generation of lift and increasing the chances of stall. To mitigate the risks associated with retreating blade stall, helicopter pilots must adhere to proper operating procedures and limitations. This includes flying within the recommended airspeed limits, ensuring sufficient rotor RPM, considering weight and balance limitations, and employing smooth and controlled maneuvers. By understanding the factors that contribute to retreating blade stall and applying appropriate techniques, pilots can effectively manage the limitations and safely operate helicopters at high airspeeds. 3332. Ground resonance is most likely to develop when A. On the ground and harmonic vibrations develop between the main and tail rotors. B. A series of shocks causes the rotor system to become unbalanced. C. There is a combination of a decrease in the angle of attack on the advancing blade and an increase in the angle of attack on the retreating blade. The correct answer is B. When a helicopter lands and one landing gear strikes the surface before the others, it can create a shock that is transmitted through the fuselage to the rotor system. This shock has the potential to cause the rotor blades near the contact point to be forced closer together. Subsequently, when the remaining landing gears make contact, the unbalance caused by the initial shock can be exacerbated. This unbalance and vibration can lead to a resonance of the fuselage, which refers to a condition where the natural frequency of the fuselage coincides with the frequency of the vibrations induced by the landing gear impacts. Resonance can cause excessive vibrations throughout the helicopter's structure, which can be detrimental to its integrity and overall flight characteristics. It is important for helicopter pilots and operators to minimize the risk of such resonances by executing landings in a controlled and coordinated manner, ensuring that all landing gears touch down simultaneously or as closely as possible. Proper training, experience, and adherence to established landing procedures can help mitigate the potential effects of landing gear impacts and minimize the occurrence of resonances in the fuselage.